Hello viewers, in this video we'll be dissecting a simple approach to calculating or taking quantities of walling units, that is block. It may not be out of place if you gain the knowledge, because this will help you to plan and forecast amounts to budget for your dream house. Alongside with it, you will gain some knowledge in Autocad 3D model. So sit back and relax while I take you through the process. And don't forget to subscribe to this channel, as more other videos showing how to calculate or estimate other building components will come your way. So we start in these very good terms. Now we have our Autocad 3D already launched. We want to produce the model of our walling unit, that is our block. We can pick our polyline. The length of the block is 450. You type 450, you enter. Still, the line is still continuing. You take it at the other direction. You type your 225, you enter. Then returning back to the length, which is 450, you enter. Then you can type C. C means close. You will see it display at the bottom part of the Autocad here. So you can type C to close up. So this is the length and breadth of our block. Now we want to make a hollow block. So how do we go about it? Let's assume that the thickness of the wallings of the hollow is 25 mm. So what do? We can still pick our polyline, look for the center line, draw across, then we still use our polyline, or if possible we can use our rectangle. Let's use rectangle at this moment. We'll click our rectangle, we'll drag open and dump. We'll repeat the same thing for the second half of the block. Then we delete this. Still continuing. This is the outer walling of the block, which is very important for us. So we click one of the half, then pick the center point, drag off, because we say we're going to make the thickness of the block wallings to be 225. So what we do is to offset this very outer layer of it. So we click our offset, type 25, then enter. It will give us the option either to offset outside or inward. Since we have already mapped out the layout of 450 by 225, we are offsetting inwards. So once we take it inwards, we click any point within the internal layers of the block, and that gives us the offset of 25 at both sides. So we now proceed. Now we can drag this to the center, and we can as well delete this. Then what we do is to click this half part of it, then we type mirror. MI can be the short form of mirror. Once you type MI, it will display a lot of tools you want to use. Since we are using mirror, we click on mirror, then we click at the middle point, then drag along the center point, and we enter, and we've already mirrored. So what we do is to push 225 off. Sorry, what we do now is to make sure that we get a center part which will give us 25 mm. So only way to get is to share this 25 into both sides, whereby we have 12.5 downwards. We type 12.5. Good. And then we align this, we type 12.5 as well. Then in some of our blocks we have like a fillet edges in terms of a curve. How do we make it possible now? You can type F for fillet, you enter, then you type arrow to represent the radius you see below here, or you click this radius, then it's asking us for radius. We have a default radius of 15, which is very okay for us, so we type enter. Then what we do is to click this one of this side, click one of this side, and you get your full curve edge. We enter again, click this edge and click this edge. So we repeat the same thing for all. Then at the end, we'll be able to achieve we having the internal curve of the hollow block. Now we proceed in this form by extruding. If you don't know how to search for the tools, you can type EX. Before you finish typing ES, you see it display. The first one we're having extend, explode, exit, extrude. Extrude is what we need. Then we click on extrude. Which of these elements do we want to extrude? We can take the outer layer, we click it, we say enter. You see it pop up. We are extruding upwards. Or better still, let's first of all extrude the internal shape, the internal opening of the block wall. Now we take the process of or perhaps you can find extrude here. You click extrude, click what you're extruding, you enter. So you can drag up, you can drag down. We are dragging upwards. So as you are dragging upward, AutoCAD is requesting to what height are you dragging up. And we know that some of our block units, we have it at 225. So we type 225, enter. So we have extruded the height of the block to be 225. So we can still click our extrude and do the same thing to this. We lift up 225. Then same thing with the outer band. We type, we undo. Then we click this. We take it up 225. Now we have our block wall almost completed, but these hollows must be removed. How do we remove it? We have a tool we call subtract. Once you click your subtract, it's activated. AutoCAD will ask you, select the object, that's the main object you want to remain after subtracting. What you do is you click what you want to keep back, you enter. Then it will request which object you want to subtract. We click the internal one here, then we enter. Automatically you find your hollow So you repeat the same thing for the other half part of the block. Enter, then you click this, enter. Sorry, we'll take it again. This, the main body, enter, then we take this. Sorry, enter. So now we have our full hollow block. We now proceed. Before then, I created a layer for the block. So what I'm going to do is to highlight and make it a layer for the block. I highlighted, go to my layer, then click the block. Automatically this one becomes a layer under block. Whenever I click on it, you see a layer called block display. Now we're proceeding to how we can get the numbers of block required in our building. Let's proceed. For instance, I map out 1 meter by 1 meter. That is 1000 millimeter by 1000 millimeter, which is the same thing as 1 meter by 1 meter. Now let's assume that we have our block being moved into this frame of 1 meter by 1 meter. Now we have our mortar, we laid on the ground, we arrange our block. We notice that 2 full blocks will be able to occupy 2 full blocks and some little quantity to complete is what we needed in the first course, or what we call the first coach 2. Then when we proceed up, we saw that we needed 1 full, another half and another, but let's not consider that we're having half now. We move to the next course, 2 full, just like we have from the beginning, and to the last course, which is coinciding with the final height of 1 meter. So if we finish arranging in this pattern, now let's count approximately. Mind you, we are estimating. Let's count approximately what number of blocks we can get in 1 meter by 1 meter square, or the same thing as 1000 millimeter by 1000 millimeter. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It then means that in 1 meter by 1 meter square, we have 10 blocks. Meaning that 1 meter by 1 meter, which gives us 1 meter square, we have 10 blocks. Now how do we apply it to the entire block so that we'll be able to get the total quantity of our block? Now let's assume we have already built block walls. Now we have our block wall already built. Some of us we have what we call our window sill. We have window sill, or what we call window level. Then we have our lintel level, then the top final level of our block. The same thing apply here, but in this case here we are not having window. What some of us do is that we don't consider to subtract the openings of this window, because in the process of erecting these block walls, you cannot tell actually how waste will come up. So it is better at the end of the project you have some leftover blocks which you can still put into use in making a fence, and as well as septic tank and other walling units you may still need in your building. So for now, we are not considering that we are going to have a window opening where we are not laying blocks, or a lintel concrete, the concrete covering the lintel where blocks are exempted also. So it then means that from this we're able to establish that if we have first 4 courses or coaches before the window level, we have 5 coaches or courses before the lintel level, and then after the lintel level we still had 2 blocks. But some people will even add one more course of block or coach, but that depends on their own choice. But now let's assume we have gotten a height from our overside concrete, or what we call German floor, to the top to be 3 meter high. Now we can still measure the distance from here to here, meaning that we can type our dimension. The dimension we need is not the linear type, but the dimension of our line. That's what we need. So we can click to know what the dimension from here to here will actually give us. Why we are facing this is because our UCS has not been set to give us this, but we can as well copy from existing. I don't want to bother you on process of setting UCS. We can copy this, then move closer to this, then we can establish, we can drag this, or if it's not possible, then we can go to UCS. We can type UCS, enter. Okay, so now we can drag. You align your UCS to the direction of either S, Y, or Z. So it means that we have area of this block length by the height, or perhaps 2.8 by 3.0 meter. So we can copy this, then move closer. Now we are having one of the sides to be having one of the sides to be 2.8 by 3.0. So 2.8 by 3.0, we can check from our calculator. by 3, standard calculator. So we have 2.8 by 3.0. That gives us 8.4 square meter. 8.4 square meters. So how many blocks are we going to have in 8.4 square meter? If we know that in 1 square meter we are having 10 blocks, it means that we multiply 10 by 8.4 square meter. That means we have 10 times 8.4 square meters. At the end, we need a total block of 84 to complete this wall we are having. We can take a simple count. One, let's not count. Okay, we can count the half as well to be one full block. 1, 2, 3, or let's leave the half out of each corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66. The full blocks we have 66 numbers. So let's add the half blocks to it: 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78. Now we have 78 block. But what we estimated is 84 blocks. Why? Because when we are estimating within 1 square meter, we consider that these halves, we are going to leave it to be part of full block, because we don't want a situation where construction is going on and the site will run out of block. So at 84 blocks for this walling unit, we are sure that we have enough block to complete the project. Now let's assume that we have our walls, we have a room, a full room that has this wall again by this side, by the opposite side, and closing it up. So simply what you do, since you know the height, what you do is to take the length, which is 2.8 at this corner, plus 2.8 at this corner, plus 2.8 at the other corner, plus 2.8 at the other corner. So we are going to say, what is the total length of the room? Which means we have 4 corners, which is 2.8 by 4 corners, which gives us 11.2. Then we use it to multiply the height of the wall, which we established to be 3 meters. That is 3,000 millimeters. So we multiply by 3.0 meter, which gives us 33.6 square meter. Now we have already established that in 1 square meter, that is 1 meter by 1 meter, or 1000 millimeter by 1000 millimeter, we have 10 blocks. So what you do, since you've established the square meter for this unit of walls, which are in 4 corners, so we'll multiply 33.6 by 10, which gives us 336 blocks. So it then means that if you have a building, we need to change our UCS. Okay. Let's say you have a building of this nature. This is your room, and we have another room, and in between the rooms you have your toilet. You still have your toilet. Then let's take this out. Let's move out from this side. Then you have another wall. Then you have your living room. You have your dining, and you have your kitchen. So we have 2 rooms, a parlor or living room, dining and kitchen, and maybe at the front of this we have a corridor wall, and perhaps at the back of the kitchen we have wall too for the corridor. So we can copy this. Say this is our living room. Highlight. We say bedroom 1. Then bedroom 2. Then we have our living room. If you want to edit the text, click fast twice. We have our living room. Then copy dining room. Sorry, need to delete one of the rooms. Then we have our lobby. We can put it in short form, LOB. Then we have our toilet, we call WC stroke bath. Then we still have the same here. Then we have, we'll copy the same text to here. We have our terrace, or what we call veranda. We still have our terrace here too. kitchen. Now, what we now do is to take the dimensions of all the walls. Take the dimensions of all the walls. Then we type dimension. We choose, because it's in 3D view, we choose dimension align. So we can take the dimension from here to here, which is 7.63. So we'll add it, we'll start the addition 7.63. Then we repeat our dimension. Here we have 7.92. We add it up plus 7.92. So we proceed, enter. If there is any command you have used before, the best way to call up that command back is to strike the key enter. In Autocad, spacebar and enter, they function the same thing. So most of the time, it's the spacebar that is closer to us to tap. But if you are very used to using enter, your enter is not far away from you, the same thing. So let's take the dimension for this. We have 7.92. We add it plus 7.92, and then we say enter to take this dimension, which is 7.6. We add it up to plus 7.6. Then we call back the command. Then we take this dimension, which is 3.56. We add it up plus 3.56. Then the same thing for this, we can call up the dimension. Okay, we still add plus 3.56. Then we call up the dimension for this internal block was separating the two toilets 1.9 meters. Then we can say plus 1.9 meters. Then we'll add up. Then we'll call it the dimension. We have 1.9 as well, plus 1.95. Then the same thing, we call up the dimension line. We have 7.6 plus 7.63. Then which of the walls are left? Okay, the wall separating. Okay, the wall separating the living room and the terrace. We call up the dimension. We have 4.35. We add it up plus 4.35. We now proceed. Which of the walls? Okay, the wall separating the living room and the dining. We call up dimension and 4.35. We add it up 4.35. Then we proceed. wall separating the kitchen and the dining. We call up our dimension. We have 4.35 as well. Then we'll add up 4.35. Then what is left is the wall separating the kitchen terrace and the kitchen itself. We'll call up the dimension. We have 1.42 plus 1.42. So in total, it means we have what we call the gate, or we call the mean gate. The mean gate means the total length, the total runnings of the block, the total runnings of the block. Take the vertical ones, take the horizontal ones. Sometimes we take it vertical or horizontal so that we don't confuse ourselves. Now, it means the total length we are having for the block is 64.14 meter. So, for instance, we have a whole length of 64.14 meter. You can type 64 in millimeter and 140. And that means if we stretch the whole of the blocks, this is the total length it will be. Meaning, from the previous example we demonstrated, it means the total length here, which we have 2.8. Now in this building we have a total length of 64.14. Now we have established our height to used to be 3 meters. So it now means that our height will be 3 meter up. So to calculate the area of the wall, we now say 64.14 times 3. Let's copy this, bring it closer to where we needed it most. We now say what we're going to change is our 2.8. We now have 64.14 times 3. That will give us times 3 equal to 192.42 square meter. 192.42 square meters. And we have already established that we have 10 blocks in 1 square meter. So to finalize the total number of your blocks needed, you say 192.42 times 10. We multiply this by 10, which gives us 1,924 blocks. So in all, we needed 1,924 blocks to complete these are 2-bedroom flat we've already established. Is it not simple enough? It is. Mind you, using this process, you are very sure of having some remnants of blocks. And let's remember that the block walls we've been calculating is for superstructure. What do we mean by superstructure? It means any structure erected above the foundation component. From this point downwards are part of the foundation component, and that's what we call the substructure. So what we just calculated is for the superstructure, and if you still have the same thing for your substructure, for instance, we have this as our foundation, so let's call this superstructure. For your substructure, what you have to change now is the value of 3, because by then we'll not be having a height as much as 3. Sometimes our substructure can take up to 1 meter, 1.2. So let's assume that we have substructure which is 1.2 downwards. So what we're going to do is to change this to sub, click fast twice, we call it substructure. So only the difference is that we're having a height of 1.2. So we can establish the total number of blocks by saying 64.14 times 1.2. This gives us area of 76.96. 76.96 square meter. And when multiplied by 10, which we established already, that 10 blocks we have in 1 square meter, we say 76.96 times 10. So a total number of 769 or 770 approximately blocks will be enough for us to do our foundation of a height 1.2 meters. So we have 769 or 770 blocks approximately. So meaning that the total blocks we needed to complete our 2-bedroom flat of this size blocks is now equal to 1924 blocks plus 770 blocks. So we have a total number of blocks to be 770 plus 1924. So we have total number of blocks to be 1924 plus 770. We have 2694 blocks. We have 2694 blocks. So with this, you're able to establish that for you to complete your dream house, your dream home, 2,696 blocks will be required. And if you check your house, you notice that the block is one of the most used components. So if you plan well in this form, it means you can make a budget, since you can get from the vendors how much it costs to have one block. So if you have 2,694 blocks and you have one block at a certain amount, you multiply and you know how much to budget for blocks. So the approach is very simple. You don't so much need an architect before you start planning. You can start in this little form. So please, you can go through the video once again and again, and you will get a better understand. Don't forget to subscribe. And another thing we have to consider too is that we have sometimes, okay, let me not bother you much on that. This is just a simple approach to achieving your block wall quantities. So more videos of other building components will also come your way, but just start with this.